Hello guys, it's Mrs. Craft and I'm creating a video for you to show you how to do graphing speed. This goes with our 8th grade chapter 1 textbook, lesson 3. Here we go. So first things first, you want to make sure that you have all the necessary supplies today. You will need 4 colors: red, orange, yellow, and green. You also need a copy of the handout that looks like this. You should already have glued in this handout next to the graphing speed page, so it goes next to the page and not on that page. This is the color coding that we'll be using for these graphs. Once again, you need the colors red, orange, yellow, and green. Please color in the color coding boxes. Red is for object at rest, orange is for constant speed, yellow is for slowing down, and green is for speeding up. We will be starting with red. Please make sure that these 2 red lines are on your handout. If we look first at the position graph, this graph has position on the y-axis, so it is showing location of an object over time. If an object is at rest, that means that it's not moving. This would be like a broken down car, or maybe you while you're sleeping at night. You probably aren't going to leave your house during your sleep unless you happen to sleepwalk or something. If the object is not moving, then it should make sense that position doesn't change. Now, time is passing, but the position remains the same. So the car that's broken down stays in the same spot while we're waiting for a tow truck. Now, if we look down at the speed graph, an object at rest is going a speed of 0. It's not moving at all. My car stays in the driveway all night and it doesn't move, so the average speed is going to be 0. So even though time is passing, our speed stays nothing. Now we're looking at orange, which is our constant speed. In the position versus time graph, you can pretend that the origin, 0, 0, is the starting line in a race. If someone is really good at pacing themselves, they can go at a constant speed throughout until they hit the finish line. This means that they're never getting tired, so they're not slowing down, and they never get a burst of energy and speed up. This also is what the graph would look like if a car is using cruise control. So, right, we set it so that you don't get a speeding ticket on the freeway, and then you drive an appropriate speed until you stop. This is a nice straight line, and it's important to know that the slope is consistent. So it's always going to have the same rise over run. If we look at the speed versus time, anytime you have a constant speed, it will be a horizontal line. Whatever speed it starts at is the speed it stays at, no matter how much time has passed. It's important to know that it's always going to be a horizontal line, but that it could be here, it could be here, or it could be the orange line that we've created. So the speed can be anything to start off with, but if it's a constant speed, it's going to stay even over time. Next is yellow. And yellow, we're talking about an object that's slowing down. Okay, so if we still think of our origin as a starting position, then this is kind of really similar to the way my weekend runs happen to go. Okay, I start off and I leave my house and I get pretty far away from my house in a very short amount of time because I'm all pumped up and jazzed and ready to go. And then I start to get tired, so I go slower and slower. Now, no matter what, I'm still getting farther away from my home, but as time passes, my speed to getting farther is slowing down too. So it makes a nice little curve here. Looking at it in the speed graph on the bottom, you should see that it should make sense. This one's kind of the easy graph. If we have yellow, which is slowing down, it's going to start at a high speed, meaning a higher number, and then the number of the speed will get lower over time. So if it's getting lower, that means it's also getting slower. And next is green, which is speeding up. Okay, so speeding up, first of all, you might notice that it's kind of the opposite of the slowing down curve. So they make kind of a leaf on our graph. But speeding up, I like to think of some grandparents. Okay, they might get really out of their chair pretty slow. They have achy joints and all that. And then eventually they feel all good and then they start walking at their normal pace, so they go quickly. But this is anything that's just going to start off slow and then speed up. Now, since you notice that they're opposites here, it makes sense that they're going to be opposites down here. And they are. Now this graph, it's showing that the speed starts at 0 and increases, but I want you to know that it can also start anywhere on this line as long as you have a positive slope. So the line could go like this, and that would still be okay. It could start way up here and just go up. That would be okay, as long as the speed you start with is lower than the speed you end with. It's speeding up. Okay, so if you didn't catch all that, didn't get to do the lines, I want you to go back and pause and make sure that your graph looks like my graph. You will need to be able to graph this on the test or recognize one of these graphs on the test.